Alright, good day students, how are you doing? This is me again, Sir Navero, and welcome to our YouTube tutorial videos. In this video, we're going to talk about, we're going to discuss about still joint variation, but this time it will be using problems as an example. So yeah, solve problems involving joint variation. So we've discussed already what is a joint variation. No? So short recap. It is when there are three quantities, related with each other and directly related to each other or jointly related to each other. So it should be at least three quantities so that it can be considered joint variation. Otherwise, if there are only two, then it's only direct variation. Now, joint variation, it has so many applications. One of which can be in geometry. For example, the volume of many shapes: sphere, pyramid, triangle, cone, triangular, pyramid. What else? So it has so many. It has a vast applications, in the field of not just in mathematics but also in engineering and physics. All right. So joint variation. So here I have chosen three examples, as to be used as a tool in the discussion, so that you may understand the concept very well. So now let's proceed. All right. So first example is, it's all about, let's move this. The volume of a right cylinder varies jointly as the square of its radius and its height. When the radius is 2 cm and the height is 6 cm, the volume will be 75.36 cubic centimeter. Now, first question would most likely be the basic one. What is the constant of variation? What is the equation of the variation? And what is the volume if r, or the radius is 3 cm and the height is 5 cm? Okay? So now let's, first things first, we always translate the variation statement to variation equation. So there, so it's the volume V varies jointly as the square of its radius and its height. So V equal to K R squared H. Now to solve for the constant of variation, we use this set of data that is given here, first set of data. Alright. Let me check. So it's just, let me move this one. Maybe down here. Or yeah, it's just here lang there. Alright, so first we substitute, the volume is 75.36 and the radius is 2, height is 6, so we square this one, we get 4 times 6 is 24k, then it's equal to 75.36, and then we divide both sides by 24. Therefore, the answer for that k is equal to 3.14. Most likely 3.14 is just equal to what? So 3.14 is just equal to pi. Remember pi? Alright, so it's just quite familiar to you. So most likely the symbol will be used, but there are times that the value 3.14 is used. So in this case, what is the equation of the variation? It's V equal to pi, or 3.14 r squared H. Alright. Now let's proceed to letter C. What is the volume if the radius is 3 and radius is 3 cm and height is 5 cm? Alright. So this will be used now, not this one now, because we already got 3.14, which is the k, so that is why we're going to use the equation this time. So if the radius, just replace the radius on the h, or the height, so there we got 3.14, 3 squared times 5. 3 squared is just 9, times 5 is 45, and then 45 times 3.14, how much is that? So the volume would be most likely, alright, so it's 141.3 cubic centimeter. So if a right cylinder has a radius of 3 centimeter and the height is 5 centimeter, then the volume of the right cylinder would most likely be 141.3 cubic centimeter. Now, questions so far? Okay. So now let's proceed to another set of example. So for this time, we're talking about interest. No? So again, another view or another aspect of application on this variation. So, a simple interest varies jointly with the amount P, principal amount, and the length of time. Suppose the I, which is the interest, is 600 pesos when the principal amount is 10,000 pesos in 2 years. First question, what is the constant of variation, and write the equation. Second, what is the interest and when the principal amount is 15,000 and the number of years is 4. And third is how much should someone deposit if she hoped to get an interest of 1,200 in a year, 1,000 or 1,200 pesos, or let's say 1,200. So let's go to let's find the constant of variation and write the equation. So again, we always translate the variation statement to variation equation. So this is most likely be equal to I equal to KPT. K times P times T. So there, we substitute lang to get the constant of variation using this set of values. So substitute. P is for 10,000, the year is 2, and then I 600. So 10,000 times 2 is just 20,000. Then we divide both sides by 20,000 so that we can get K, remember? So we divide both sides by 20,000 and then this will be cancelled. And then if that's cancelled therefore our K will be 3 over 100 or 0.03. Either way, we can get the value of what is being asked. So there are others that will be using this one, and there are also some that are going to use this one. So that depends. It's the same naman. Anyway, the value it's not an irrational number. So either way, we can just use this too. So let's proceed. To write the equation, we replace the K here with the value of 0.03. So therefore, the equation is 0.03 PT. Alright, now let's find let me erase that one. Now let's find what is being asked in letter B. So what is the interest? What is the interest when never mind this T, when the principal amount is 15,000 for 4 years? So just replace its interest is being asked. Replace the P and the T. 0.03 times 15,000 times 4. So 15 times 4 is just 60,000, and then times 0.03. How much is that? That is equal to, alright, so it's 1,800 pesos. So the interest when the principal amount is 15,000 for 4 years is 1,800 pesos. So yeah, you have to write the sentence form. Alright, let us see how much should someone deposit if she hoped to get some interest of 1,200 in a year. So the same formula will be used. We'll be using this one. So there. Then it's not asking for the interest, rather it's asking for what? We have here the interest 1,200 and year. What is it asking for? Alright, so it's asking for the principal amount. So we just replace the P, we just replace the I and T there. So 1 month, 1 year, so 0.03. Divide both sides by 0.03, therefore the principal amount is 40,000. Alright, 40,000. So the principal amount, if someone is hoping to get an interest of 1,200 pesos in a year, is 40,000 pesos. Questions so far? Questions? Okay, let's proceed to the last example. Okay, the area of a triangle varies jointly with the base and the height of the triangle. Suppose the triangle in the Bahamas flag has a 1.3 meter base and a height of 0.3 meters and an area of 0.195 meters square. So again, mostly the questions are similar naman. Solve for the variation constant and then write a variation equation. Second question is, what is the area of the triangle when the base is 65 meters long and the height is 25 meters? Suppose the height is doubled and the base remains constant. How does the area of the triangle vary? Try some values. So there we get to go solve for A. So we translate this by using representing values. Area for A, B for base for B, height for H. So there, we just replace this first set of data, no? So area 0.195, base 1.3, height is 0.3. Then we multiply, this is on the right side, that is 0.39. Divide both sides by 0.39. Therefore, we get K is equal to 1/2, or how much is that? 1/2 or 0.5. So therefore, the equation is A equal to KBH. Just replace the K with either 1/2 or 0.5 BH. So A area is equal to 1/2 base times height. So now let's find letter B. No, this is our constant of variation and then our equation. So letter B, what is the area of the triangle when the base is 65 meters long and the height is 25 meters? So we replace the B and the height. So B there is 65 na and the height is 25. So I forgot to write it here, their products, no? So we replace 0.5 times 65 times 25. You can check it there. How much is this? 65 times 25. I think it's 1625. Just to verify, no? 65 times 25. Yeah, it's 1625. And then half of it, or times 0.5 of it, is 812.5 square meters. No? So square meters. Sorry, this is not centimeters. Square meters. Alright. Let's proceed to letter C. So, suppose the height is doubled and the base remains constant. How does the area of the triangle vary? Try some value. So, the answer to the question is, it will also be doubled. For example, no? So, we'll be using the values here in letter B. Okay, so it says here, the base remains constant and the height is doubled. So, take note the height is, pila to? 25, no? 25. And when it is doubled 50. But the base is still the same, no? 65. So we will be using these values 50 and 65 to be replaced in the base times height. The base this time is still 65, but the height, no? Here, unlike here, we use 25. Here we'll be using 50. So let's compare their area. So 65 times 50, how much is that? Okay, 65 times 50 times, it's 3,250, no? And then you divide it 3,250. Then you multiply it with 0.5, the answer will be 1625 meters square. Alright, 1625 meters square or square meters ang area. So meaning ni double ang iyang area, thinking na gi-double nimo ang height tas gi-remain nimo ang base. Same pod kung balihon na to. Let's say i-double nimo ang base, i-remain constant nimo ang height. That will still double. Or kung triple ba, at least one, basta ang usa nila. Sir, what if duha ang i-double? Then you can check it yourself. You try to check it in yourself. I will not say the answer, but yeah, you check it. What will happen if the two variables will be doubled? So will it still be doubled, or will it is it doubled or something? You discover. Alright, so I think that would be all. I'll just have the other video for the next part of this. Thank you and God bless.